Hi, this is Derek Tsai from LearnByBlogging.com. Today I want to give you a review of this book. It's called The How Not to Be Wrong by Jordan Ellenberg. Jordan Ellenberg is the author of this book, How Not to Be Wrong, The Power of Mathematic Thinking. Overall, it's a very interesting book and a little bit hard to read if you are not mathematically inclined. And so the book started out with the missing bullet holes for back in the old days when the World War II happened. When the fighter plane came back from their battle, they saw the bullets all happening in the fuselage, but there's very little bullet holes near the plane and near the engine, and so they're suspecting that they should just beef up the fuselage. And it turns out that this statistician came in and said, well, he asked a very smart question: what happened? What are the missing holes in the engine? Well, it turns out when the engine actually got shot at, they don't make it back. So that goes to tell you that very, very profound and very simple thinking. So the book is focused on the profound and the simple quadrant. So it came up with this complex, simple, and profound and trivial. And he's focusing on the upper left-hand quadrant. And I don't know whether he did a good job or not. It seems to be awfully complicated. And well, first chapter, he went through this linearity when most things are not linear, and there's always a min and max. So the Laffer curve, he went through a description of how the Laffer curves happen on a napkin, and we came up with the Reaganomics. Because when you raise the taxes, there's optimal amount of tax rate that you want to do to maximize your tax revenue. And also they talk about the linear regression. Interesting statistic that every SAT point will cost a parent an extra $28 in tuition back in those days. So when a university has a higher students with a higher SAT score tend to charge more, and they end up paying more for that. So that's linear regression. And you don't always want to extrapolate linearly, especially when you extrapolate the population of people going to be fat or obese, and extrapolate that, eventually you get 100%. And that's not likely to happen. Things real life don't extrapolate very linearly. And he also talk about the law of large number. Like a coin toss tend to converge to 50% when the number of tries goes up. And the best NBA player, free throw player, actually are the players that you never heard of because they don't play enough games. So large number of tries are really it's a very interesting concept that he actually put together, is that it's not that the probability is going to be leaning toward the other side if you have a lot of previous events that are biased toward the other side. It just happened that if you have a lot of heads, you throw a lot of heads, doesn't mean that the probability is going to be a lot more tails. That's not true. It's just that eventually the large number of tries is going to dilute the previous results, and there's no change in probability. So that's a very important concept. And he also touched on the percentage, using the percentage of numbers when the numbers are negative. Very important concept there. So these kind of the first part he called linearity. And then second part, it goes to inference, and that he's talking about the Baltimore broker. The Baltimore broker is the people who actually send out this prediction, and if they are wrong, they don't send it back to you, and then they're going to send to whoever that happened to guess right. And then if you do it so many times, eventually they're going to be right all the time. They eliminate the one that they are wrong. The people that they send the mail to, if their information is wrong, they just don't send next time. So eventually, after X number of time, if you keep receiving them and you keep hearing the same correct prediction, most likely they just happen to be trimming down the area, the people they are actually that they predicted incorrectly when they send it to those people. So the same thing happened when you have a when you guess enough time, and eventually you're going to be right if you tailor the outcome to your guesses. So that's the Baltimore broker example. And then he goes through the Reductio Ad Unlikely. This is actually a very important concept. Is suppose if a null hypothesis is true, it follows that that certain outcome O is very improbable. Usually use a p-value of less than 5%. And if O is actually observed, then H is very improbable. So this is how you usually do statistics. You do the same argument as such, Reductio Ad Unlikely. So that's a very general body structure of how you argue why things are more probable or less probable. And he went through example of the Bible quoters, why people think that why people predict that the God exists, because it's just not very improbable, since that is very unlikely that the human can be developed and created by itself randomly to be this kind of perfect shape, or the environment, the earth, or provided will be created in such a perfect shape as we see today. It's a complexity. Therefore, God must exist. So that's kind of the argument that he's making. How do people use the inference? The expectations. This is the third part. Massachusetts State Lottery. He went through the expected value is actually should be called average value, because you really don't expect to win a lottery, but the average of time the expected value or the average value of your lottery ticket is just whatever the jackpot is divided by a number of player, or the probability that you're getting winning the jackpot. And he goes through very laboriously how the people actually game the system, not game the system. They actually play the windfall and able to come out ahead with a very high expected value, and able to win a majority of time or make money out of it. So that was a very interesting story that he put together. And then he goes through utility theory. You want to maximize utility as versus missing the plane. This one economist called Stigler argued that if you never miss the plane, you are spending way too much time in the airports. So that, basically you are trading your utility value of getting too early to the airport versus missing the plane, and you're making some trade-off there. So, and he used some geometry by picking, and also he mentioned about certain way of picking the random lottery number, and how he tied that into the Hamming code, which is used to do error correction or error detection in a lot of the computer error correction code. So that was very interesting for me, because I kind of use that every day. And on the fourth part, he goes through the regression. He talk about the triumph of mediocrity and the scatter plot of the father-son height, since we have an oval shape instead of a diagonal shape, because there's a certain probability distribution. And that's the fact that there's it's kind of intuitive, but there's actually a lot of story behind the oval shape. And then he talked about the correlation is not transitive, just like my daughter is related to me, and my daughter is related to her mother or my wife, but I'm not blood related to my wife. So this kind of use that as example is that you cannot transfer the correlation. That's a very important concept. That's how a lot of the drugs fall apart when it comes to effectiveness. Just because most likely correlate with certain symptom, and also B correlate with certain symptom doesn't mean that A can correlate to B. So that's an interesting story. And then he talked about the Bergson's fallacy. Why is the handsome guy is always mean? Because we have a selective population of how we pick people. We tend to he drew this curve, and this upper right hand corner tend to be people you actually pay attention to. So the mean, you don't pay attention to the mean and ugly, and so you kind of automatically take that out of your population. So the smaller population that you have tend to be, there's a little triangle shape, and they tend to be the nicest guy on this side tend to be, and also there's some ugly, mean guys on the other corner. So there's some interesting explanation on the graph, and that goes to a lot of the hospital, a lot of the drug usage as well can be applied there. So okay, the last part is about existence. So we kind of wrap up in this coexistence. And he goes into great detail about public opinions, polls and all that, political polls. And he goes through a very detail about Bush, Gore, Nader election back in 2000 something. And then there's a mathematical way of how best to elect public official when there are more than 3 candidates. So if there are 2 candidates, easy, majority win. But if there are 3 candidates, this third person tend to kind of stir things up and makes the actual will of the people very difficult to interpret. And as in the case of the Bush-Gore Nader election in Florida. And also he went through this Contorcha's paradoxes, a lot of painstaking details. So overall, how to be right is about applying mathematics to your everyday life so that you can be right most of the time, and don't be lazy and just take the shortcut, and mathematics can help you in that way. Does that help you to answer the question, when are we going to ever use the mathematics as was the original intention? I don't know. I don't think it would help my daughter to be more interested in mathematics anyway. So my general comment is that you probably want, if you want to read this book, the ebook or hard copy is probably more useful, better than the audiobook. I started with the audiobook and it was very easy, very hard to follow. And if you have a book, there's a lot of graph, much easier to visualize. And there's a lot of good history about mathematicians and some of the how they use their theorems came about. And this is very good. If you are into mathematics, that could be interesting. And overall, it's not a book for the faint of heart. You might need some mathematics background and maybe a lot of interest in mathematics to be reading this book to the end. I had to really struggle through it. So that is the end of the story, end of my review of this book. And I hope you enjoy that and you find that useful. Again, I don't recommend 100% to everyone about this book unless you are mathematically and technically inclined. So that's all I have. Until next time, thanks for watching. Bye now.